Welcome back. This video is about branching and conditionals, informally known as if statements or switch statements or any other thing that the computer uses to make a decision. So here we're going to be looking at, for instance, true versus false, how to make a condition, and how to, depending on the value of some expression, decide whether or not we're going to operate a block of code. So with our first exercise, we're going to look at a little puzzle, which is to evaluate an expression that is true if a given character variable is an uppercase letter. So let's give this a shot. Open a new notebook. This is going to be your first exercise. And here is what we're trying to do. Write an expression that evaluates the true if a character variable is an uppercase letter. So let's take my character variable called letter, and let's assume it's A. So if this expression works, it should evaluate this to be true. Now, there is a shortcut if you happen to know a function that will determine if it's an uppercase letter, but let's say we don't know that. Let's say that we're just given, all right, we have a letter A, we need to know whether or not it's an uppercase or not. Well, if you don't really know any better, you might think of doing something like, is it A, is it B, is it C, is it D? And after 26 lines of comparisons, then maybe you eventually find it out. But this takes forever, and we can do things a lot faster by taking note of, if you remember from our last little video, all of these variable types all are represented as numbers. So if I look at, for instance, the integer value of A, 65, means it's actually just a number in the computer. And Z is 90, and the computer actually has all of the alphabet of uppercase letters right next to each other in order from A to Z, which means that if I want to figure out if something is an uppercase letter, I just need to know is its numerical value between 65 and 90. So I can say, assuming that my letter is less than or equal to 90, and my letter is greater or equal to 65, then it's true if this is an uppercase letter, and if it's anything else, it is false. Now, 90 and 65 here are confusing. Where do these numbers come from? And once again, we just remember the computer thinks these are the same. So I can actually just say, is the computer less than Z or greater than A? And it's the exact same thing. Not true for this, true for capital G, not true for %, but true for M. And that's it. All right, not too tricky of a puzzle if you happen to know that you need to do some comparisons. You need to do another operator here, and, meaning both sides of this have to be true. It has to be A or after, and it has to be Z or before. And there we go. Okay, let's do our next one. An if statement. Write a program that initializes the character, then prints a message only if the character is an uppercase letter. Well, we can definitely take advantage of this code that we've written here, and so we're just going to duplicate our notebook, call it exercise 2, and let's do a new problem. We're going to initialize a character, there it is, print the message only if it is an uppercase letter, and we know this is a condition that is true when it's uppercase. So if I take this and surround it in parentheses, and I say if this is true, then print a message. It is uppercase. Okay, what did I mess up? Use of undeclared identifier letter. I immediately see what the problem is. The numbers on the left here indicate when did I run these code blocks, in which order. And I haven't actually run this one. I ran it like 12 times in the previous notebook, but I haven't run it yet. And I ran this one once as its very first line of code, which means that the computer doesn't even know what the letter is yet. So to fix this, I can either run this one, then this one again, or better, rerun everything from the start. Restart the kernel, run everything from the top, and now we can say, hooray, it is uppercase. And again, I can test this, change it to a lowercase letter, and now it will not print that message. Uppercase again for G. Now, this format is fine, although it's not the best. And the reason for that is that when I have an if statement and follow it immediately with a statement, I could only have one statement here. If I tried to write more statements, it would not be super happy. So it may be the case that you have a condition that determines whether or not a whole bunch of code gets run, in which case you should put braces after your if statements. These braces encapsulate all the code you want to run if this condition is true. So I can even write this message a whole bunch of times if I feel like it, as long as all the code I have is surrounded by this brace and this brace. And the encapsulating characters we're using here do matter. You have to use parentheses here, you have to use braces here, and later on the course we will use brackets, which are the squares. This little double slash here, by the way, is just a comment. It doesn't tell the computer to do anything. Okay, so that's enough for this exercise. Let's move on to the next one. So exercise number 3. Nesting if statements, putting them inside each other. Write a program that compares two integers and prints out a message to say which is larger. If the first one is larger, also print out a message if their difference is less than 4. So this is a lot to wrap your head around. So let's just do one part at a time. Always a good lesson from these kinds of tricky problems is to break them down into smaller sub-problems, and then you can combine your solutions later. Okay, we don't actually need this stuff anymore. We do need this, though. Okay, compare two integers and print out a sentence to say which is larger. So we're going to have int x equals 10, int y equals 100. Here I'm using x and y mostly because these are pretty standard algebraic variables, but probably it would be better to give these different names if I'm using them in a larger program. First number, second number, something like that. But for here, x and y is okay. Okay, we want to compare them and print out a sentence to say which is larger. So if x is larger than y, then I will print x is larger than y. Else if y is larger than x, then I'll print that out. Otherwise, there is one last possibility, which is that they are the same. Oops. X and y are the same. All right, let's see. All right, y is larger than x. That makes sense. What if I make x larger than y? Hooray. And what if I make them the same? Okay, so we've done the first part. Print out a message to say which is bigger. If the first integer is larger, also print out a message if their difference is less than 4. So if the first integer is larger, also print out a message if their difference is less than 4. And what is their difference? Well, it's the first one minus the second one. And if that is less than 4, and remember, we know that if we're in here, that x is bigger than y, so this has to be positive. If this is the case, we will say, but they are close. So here I've basically written one if statement inside the brace range of the other if statement inside the block. And this will only happen if this also happens. So we go from top to bottom here. We say, okay, let's make them real close. So let's do 5 and 6. So x is bigger than y, but they are close. So when we go through, we say, okay, is x bigger than y? Yes, it is. So we move into the block and we say print x is larger than y. Then we compare them. What happens when you get 6 minus 5? It's 1. 1 is less than 4. So we will then print out this message. And now we get x is larger than y, but they are close. And if I switch these so that y is bigger than x, it just says y is bigger than x because this whole thing that I wrote in does not appear under this block. And that's how you nest an if statement inside another if statement, which you will see all the time in C++. All right, on to the last one. One more. Okay. Write a program that uses a variable representing a letter grade, then uses a switch statement to make an amusing comment about how well that student is doing in the course. Don't forget to account for invalid letter grades. Okay, so switch statements are not used all the time, but they are something that are worth knowing how to use in case they ever do come up. C++, exercise 4. Here is our problem. Okay, so we need a variable representing a letter grade. So a character grade, and let's say we have an a nice grade to have. We're gonna use a switch statement. So we're going to make a switch that runs on the grade. So switch parentheses grade. And then in the braces, here we're going to go through the different cases of what the grade could be. And the grade could be an A. We'll write a colon after. And if they got an A, we will say, wow, you're so smart, with a wink. And then after your case, you need to write the word break with a semicolon. This is important to make sure that you don't actually look at every single case. We just stop at the first one that matches. We're going to do this again for each of the letter grades that we can run into. A, B, C, D, F. And we're going to have one more, which is the default. And this is if we put in something other than a valid letter grade, which will just be the message invalid letter grade. B is, of course, totally fine, I suppose. C is one of the letters of all time. D is for duh. And F is perhaps this is not your best work. Very, very realistic messages that you might see in somewhere. And so when I run this, say, wow, you're so smart, because we have an A. But if we have a C, is one of the letters of all time. And if I put in something that isn't a letter grade, like an exclamation mark, it will say invalid letter grade. And there we have it. We've now written a basically equivalent to a whole bunch of ifs that allows us to check for all the different letter grades we could get and to write out a simple little message for them. So that's it for our branching exercises for the day, and I'll see you next time. Bye-bye.